Hi everyone, welcome to the video on maximum and minimum problems. In this video I'm going to be looking at a lot of in these videos I'm going to be looking at a lot of worded problems and how we can go about solving them for the maximum and minimum points. Now, the thing with these problems is that in not all, but in many cases we're going to have more than just the two variables x and y that we're used to dealing with. So it's a really important thing. We have to use this information and try and make it so it's in terms of just two variables. And then, we're able to sort of solve it from there by using our differentiation. So this first problem is quite standard. We have two variables x and y which are defined such that x to the 4 y equals 8, and the third variable z which is defined by z equals x plus y. So find the values of x and y which gives z a stationary value which is a minimum. So the first thing I'm going to do is I'm going to use one of those equations to basically get rid of one of the variables. And I'm going to use the first equation which is given to us. So if we have x to the 4 y equals 8, I can get y in terms of x by just dividing by x to the 4 on both sides. So I get y equals 8 over x to the 4. And basically that's the y value which we're going to be using here in the second equation. So I'm just going to sub that into the second equation. So that means then that z is equal to x plus 8 over x to the power of 4. So that's looking pretty good at this point. Now we want to make sure that this is going to be a minimum, and what I've actually done is I've made the graph of this on the calculator. So there it is right there. We can see that it only has one stationary point, which is right here. So that's definitely a minimum. You can see there's no other stationary point out here. It's just curving like that. But yeah, it definitely has that one stationary point. So what I'll do next, continue this over here. I'm going to get dz dx. Before I do that, actually, I might rewrite this here as z equals x plus 8x to the minus 4, because that's just going to make it a bit easier to deal with. So when I differentiate that, I just get 1, and then it's going to be minus 32x to the negative 5. Now, the next thing I need to do is make this here equal 0, because that's where it's going to be a maximum. So I'll just say let dz dx equals 0. So this is going to give us our maximum and minimum values, and that gives the equation 0 equals 1 minus 32x to the negative 5. I'm going to just add 32x to the negative 5 on both sides of the equation. So 32x to the negative 5 equals 1. Continue this up here. I'm going to divide by 32 on both sides. So x to the negative 5, I'm going to just rewrite it as 1 over x to the 5 equals 1 over 32. And, well, we can basically see just by comparing these that, well, 1 is in both the numerators, so these denominators must be equivalent. So we can say that x to the 5 is equal to 32. And so that gives us x equals 2. So that's just one of our values. Now we also need to get the y value, which makes z a minimum. So to get the y value, I'm just going to sub that into one of the equations. I'm going to sub it into the first one, which, well, I'm going to use the rearranged version of it. So y equals 8 over 2 to the power of 4. And that is 8 over 16, which is just half. So that's it. We have the x and y values which give z a minimum value. And, well, I hope this is going to work, but if I have a look at the calculator again, if I go analysis gsolve min, okay, well, the x coordinate definitely worked out to be 2.